Recording. Okay, so welcome everyone. So yeah, today is about solving the technical interview. One of the reasons I wanted to be here is just because. So for those of you who don't know too much about me, I was originally a finance major as a freshman, and going into my sophomore year, I wanted to pivot and like do something tech related. And so I was kind of like, and I hadn't really taken anything. I didn't even take data structures yet, actually. So I was, kind of on my own to look for resources and like ways to prepare for interviewing. And I think there's definitely like I went through a lot of failures and successes. So I think it'd be nice if you guys can learn a thing or two from my experiences. But yeah, so the first thing that happens is actually let me just share my screen. Which screen? Let me find it. Is that a REPL? Hold on one second. There. Do you see like a that work? You just see like a blank page. All right, awesome. So, as I mentioned in the last session, there are two main kinds of or portions of interviews. Um, Most sections will contain like a behavioral portion where they talk about your resume, and then after that, most of the time they'll delve into a technical question or like a leak code based question, which is usually like solving some kind of problem by writing code and talking about runtime and things like that. Most of it you learn in data structures, but there's also some things that aren't covered that might be asked, and just um, better ways to go about solving these kinds of questions. Just also know as a footnote, some companies, especially the not the tech giants, like the companies you guys have all heard of, maybe like startups, some of them who are looking for more specific stuff, they might ask things like more practical. So they might ask you like, even things about like the Bash terminal or Shell or Linux. I personally, most of the time, if you apply for these mid-sized like to large companies, like if you've heard of Square, Stripe, anything you've heard of like BuzzFeed, things like that, and anything larger than that, most of the time they'll just delve into these kinds of questions. So I think this is what you can mostly expect. If you have any clarification as to if you want to clarify what your interview is going to be about, you can just send an email to your recruiter. Um, but yeah, so the first thing is most of the time, like I know a lot of you guys might be doing practice or doing some kind of problems either from classes or just on your own on these kinds of algorithm problems. They might be on like HackerRank, you might have heard of, or LeetCode. And a lot of the time you'll see like a terminal where like you type in a bunch of code and you can press run and it'll run against a bunch of test cases and you can see whether you passed or not. Um, just know that I'd say most of the time, so I know for sure like, Google, Bloomberg, Amazon, Facebook, they all use pretty much different versions of the same thing, which is they just use a shared coder pad. And while a lot of them will offer the functionality to run, generally speaking, unless they tell you to, you're not running your code. What that means is it's up to you to find out your syntax, your syntax is correct, make sure your code runs fine without you being able to run it. And so that means that you need to be pretty precise and pretty accurate when you write your code, because these kinds of small errors, they do dock points on you, and they don't look great if you have to keep pressing compile and then going through your errors and then fixing them one by one. So yeah, so just get comfortable coding in a coder pad. This is what's called a REPL, or it's basically just you can see like it's a fresh method here, and then you can click run when you need it. Just get comfortable coding on your own without the help of like a run button or running against test cases and stuff like that. Um, Most of the time, what will happen is your interviewer is just going to either copy paste like a couple lines on here as to what the problem is, or he or she will just tell you. And today's problem, it's actually going to be a really simple one. And I think most of you guys have probably heard of it. It's called two-sum. Most of you guys have definitely seen it before. If you go on leetcode.com, it's actually just question number one. But I think the reason I'm using such like a quote unquote basic question is because I think a lot of people can get the right answer, but they don't get like full marks on an interview because of the way they describe how they arrived at the solution, and also how they describe the runtime and things like that. And so just as a precursor, a lot of the time these interviews aren't about, arriving at the best answer in the fastest amount of time with the least amount of help. It is like definitely getting the best optimal answer in terms of like runtime and memory trade-offs is really great, but the interviewer needs to get a good gauge and sense of how you think as a person, and like how do you crack down on what is like the methodical approach you take to arrive at your answer. What are the other solutions you considered, and why are those bad? And being able to talk about that is really, really important. And I think that's actually what the difference maker is, because if you're in an interview and you're on the phone with that person and you don't say a word and you just code out the best solution, that doesn't tell them anything. It tells them that maybe you had you Googled the solution on another window and you typed it out for them. But being able to, talk about your solution line by line as you type it and say like why your solution is good compared to others, that's what really makes or breaks the interview, in my opinion. So yeah, so we're gonna go to two-sum. If you guys haven't heard of it, it's basically, so imagine you have a target. So I'm gonna comment that. You have a target, which is like, let's say it would be 7. And given an array of numbers, so let's say you have like something like this. Let's do like, you need to be able to return the indices. So given an array of numbers, you need to be able to return the indices of the numbers that add to the target. So that's why it's called two-sum, because you're finding two numbers that sum to the target you want. So in this example, like 0, 1, 2, 3, 4, you have, so your answer would be, you want to return 4 and 5, because at index position 4 and index position 5, 2 plus 5 adds to 7. It's not like a super complicated question. I'm sure a lot of you can get it, but yeah, we're going to talk about how to go about it, basically. Also, as a footnote as well, use any language you're comfortable with, but I strongly prefer and recommend Python, just because, for example, we're going to be using a dictionary, a hash map in this solution, and in Python, it's just that, and you're done. Whereas in Java, you have to specify, hey, interviewer, I'm going to be importing the Java util hash map, and then you have to declare it with this entire long declaration over and over. There's a lot of boilerplate, and I think it's much simpler if you use a simpler language, but use whatever you're comfortable with. So first thing is find your solution, and we're going to assume that it's going to take an array called nums and a target called target. Right? And so the best way to arrive at the optimal solution is to first consider, the first thing you should talk to your interviewer about, in my opinion, is the brute force solution. And usually the brute force solution is like the solution that comes to mind and is usually very, very inefficient. So like, I think for a lot of you, you would be able to come up with a solution where you just have 2 pointers, or like you have a nested for loop and you're checking every pair of numbers in the array, and you just check every single pair. You add them up. If it's up to the target, then you're good. You return the indexes and you're done. And if you don't reach a solution by the end, then you know that target, the sum doesn't exist, and you return false or -1, -1, something like that. And the most important thing is definitely bring up these brute force solutions. Even if you have no intention on coding them, it's really important to the interviewer that you're able to understand what is the brute force solution and why is it bad. And I would add a line like, after you describe the solution, you can say, oh, it's bad because you're duplicating the amount of work you're doing. For example, I visited, index position 1. Like, I know a 1 is here, but I'm checking this 1 n times because I'm looping over it. I'm using a nested for loop and I'm iterating over it n times. Whereas, if I use, a different data structure, I can actually store the location of this number, and you're consciously making a trade-off of memory for runtime. So you can say in the brute force solution, the pros to that is that you use constant memory, because you don't use any other array or dictionary or hash map or anything like that to increase the amount of space you're using, which is good, right? But you can say that for the most part, this memory is trivial in most cases, and being able to optimize the runtime from something that's O of n squared, which means that, I'll talk about runtime at the end, but being able to optimize the runtime into something that's O of n is a lot better. And so let's start. So the first thing is, the way to get the optimal solution for this problem is, and a lot of the time when you think about number arrays, the first thing you want to think about is using a hash map, because that's going to be the answer a lot of the time. And I think a lot of candidates don't even get there, to be honest. But yeah, so if you just imagine, what is a hash map, right? A hash map basically, the pros of it is I can check if a number exists in it or does not exist in it in a constant amount of time. Like, oh, it's called O of 1. And so I can do, actually, before you even begin, one thing is you want to, if you have any confusions or clarifying questions, you should ask them in the beginning, and also ask about edge cases. So the first thing I would actually want to ask is, oh, can the array, like, can they, what if the input is an array of size 0 or size 1? Will they give me that? He might say, oh, there might be, or he might say, oh, there aren't. And if there might be, then you need to, check for edge cases, or your code will just break immediately, right? So the first thing, let's say he says there might be a code of an array of size 0. Then I can just say 2. So this is like a simple edge case check, right? I'm saying if there's not at least 2 numbers in the array, there can't be an answer. I'm done. Then moving on, the first thing we want to do is instantiate a dictionary, right? So actually, it doesn't like the name I'm using. Let's try D. Hello? Oh no, because I didn't close it. But anyway, so I'm instantiating my dictionary here, right? And what the numbers you want to get a sense of, like, what your data structure is going to look like once you start iterating. And so it's, just for simplicity's sake, taking this example, it should look something like the key is going to be 1 and it's at position 0, 3 is at position 3 is going to be at position 1, etc. Right? So that's what I want my dictionary to look like, because then I can look up, oh, does 1 exist in here? Does 3 exist in here? And when I want to check for its counterpart. Next up, it's pretty simple. I just iterate through the array. I'm going to use blah. I'm just going to type it out first before I talk. Yeah. Okay, so the first thing I'm doing here is I'm iterating through my array, right? I'm checking each number, and I'm saying that if let's say the target number is 7, right? And my current number is 4, that means I'm looking for a 3 as a counterpart, right? And so all that means is that I'm looking for the counterpart to my number, and then so I'm searching for, if my current number is a 4 and I'm searching for 3, then if both of these numbers exist, then I know I'm good. I know I'm good to go, and I return I, which is the index of the current number I'm at, as well as this funky thing, dict target minus nums I. This is just the position of the number of the counterpart. And so, for example, let's say I was here, I was at this 3 and this 4. Then what would happen is when I reach this 4, I would find the 3, and then trivially I would return 3 and 1, which are the positions of my indices. And if there's no pair, then all I need to do is I need to store, let's see. I just store the dictionary value. So this would look like, this would be like the 1, 0, right? So if the current number, index position 0 number is 1, and I'm storing it because it's an index, the I value is 0, yeah. So yeah, and then when I'm done iterating through everything, if I don't have a solution, I can just return, no solution. And so that's actually all it is in terms of the code. But okay, so the difficult part here is definitely being able to code while you type, and being able to talk through your thought processes while you're typing and while you're coding through your solution, right? Obviously, it's pretty hard to make sure that you don't have any syntactical errors or any off by 1 errors. But I think a lot of it comes with practice of, doing problems and getting used to working with arrays and iterating and stuff like that. But yeah, so as I mentioned earlier, I think a lot of people, maybe a good amount of people actually would be able to come up with a solution right here. But just because you got this solution right here and you type this out doesn't mean that your code is perfect, right? And that you got the job. What is really important is that, like, you want to be able to talk about this solution as opposed to other ones. And so in this case, I would say there's really only two main ones, which is the brute force solution I mentioned, and then the also the Hashmap optimized one. But you want to, again, be able to say like, I use a hash map because it allows me to achieve constant lookup time. And what that means is that now whenever I'm looking for a counterpart, like I'm looking for a target 7 and I'm in the number 4, when I check for number 3, it doesn't take me a whole loop iteration. It takes me O of 1 time because I'm just checking in a dictionary, does 3 exist here? And that's all I'm doing. Being able to say that is really, really important because it shows that you have a good understanding of data structures and like why you're using specific ones, rather than like, if you don't say anything, there's a good chance your interviewer will think that you memorized the question or you know, Googled some answer or things like that. Basically, you want to prove that like you actually know what you're talking about. Um, yeah, so this solution is, I would say it's pretty clean. Generally speaking, you want to keep your code as clean as possible, although not always possible. And yeah, so beyond that, like, so thinking about when you just got into the interview room until when you finished, the entire timeline should look like this, right? So he or she will give you the problem. And first of all, you want to ask clarifying questions such as, oh, like, what kind of edge cases, like, think about what kind of edge cases you might be expecting, right? Can I get an empty array? Can I get negative numbers, right? Stuff like that. Will negative numbers affect my code? In this case, it won't, right? I thought about that. So clarify any questions, right? And then immediately, you're obviously already thinking about what's the best answer, right? How do I get there? And the best way to do that, I would say, is juggle through all the data structures you have for most of these kinds of questions. Other kinds of questions, though, like some of them don't really use data structures. Like for example, if you're reversing a linked list, it's just a matter of implementing it. But for this case, you know, you're thinking about all the data structures and all the solutions you can use. And once you can say, oh, like, interviewer, may I have like a couple minutes? And I think that's fine, but try not to stay silent for too long of the interview because it's kind of awkward. It shows like you're taking a little bit too long. But then when you start talking, the first thing you want to go over is, what is the brute force solution? What is the runtime of the, like, what is the algorithm of the brute force solution? What is the runtime of the brute force solution? And generally speaking, once you give the brute force solution's runtime, you can justify as to why it's bad. So for this question, you would just say, so it's bad because every time I'm checking for a counterpart, I'm iterating through the entire array again, which is O of n. And when I do an O of n operation n times, my overall answer is O of n squared, which is really slow. By the way, for these kinds of questions, for the most part, people are always dealing with big O, which is worst case runtime. If you're not too familiar with big O, data structure should give you a pretty good lesson on it. But in general, big O, best case and average case runtime are not used as much in interviews. They want to know big O, which is worst case runtime. And then, so you talk about, you know, as I said, like you're iterating n times through an n-sized array n times, which is O of n squared. It's really slow. How can we make that better? And you can just jump to whatever solution you had in mind. So this example, you would say, I can use a hash map to make my lookup times constant, and then my overall runtime will be O of n. The trade-off, of course, is that my memory is going to be O of n because in the worst case, I have to store the entire array into a hash map, but that's O of n space, and I think that trade-off is worth making. That's what you should say. And then beyond that, it's coding the answer in a way that adheres to edge cases. So yeah, you've given your solution and then you've coded it up and you talked about why it works. The next thing he'll tell you to do is to write some test cases for yourself, right? And so it's not like LeetCode where they just give you a bunch of test cases on your own. What you're going to have to do is you literally have to go like array equals like 1, 4, 5, 9, 11. And then you have to say target equals 20. And then generally speaking, he or she will not make you run the code, the actual code, but there is an implication that it should work. And just know that, so most coder pads like this, you see how we have syntax highlighting and they do tabs and stuff like that, and it's pretty nice. They do syntax highlighting for you. I know at least when I was interviewing for Google, they just give you a Google Drive doc. So there's nothing, like you don't have anything to work with and you can't run your code. There's no syntax highlighting, there's no nothing. You just need to be able to, you just need to be really confident in, you know, writing your own code. So for that end, you can just say, he or she will most likely tell you to say some test cases, right? And if possible, give test cases that cover like a wider variety of scenarios, I guess. So there's not too many edge cases in this kind of problem, but you can just give an answer where it's like, I guess one edge case I can think of is like, um, let's say your target is 14, right? And you have two of the same number. That becomes something different, right? Because you want to be able to check that your algorithm can find its own number if it exists, right? And I know my algorithm can cover that. One thing about your test cases is your interviewer there's a really good chance that your interviewer is going to make you walk through your test cases. So he or she's going to say, oh, I like this test case. Like, can you walk me through how your algorithm would run in this case, right? And it's also a good way for you to, find bugs if you're there. And another thing is, let's say your algorithm has a bug in it, but you haven't seen it. The interviewer might point at a specific test case as a chance for you to point out and find your own bugs. And that's really important because if you miss it, then it's like they give you two chances and you missed it both times, basically. But so for the example, like I'm going to use the second example right here. So, so I'm going to iterate through this array, right? So the first time my dictionary is empty and I have, target 14 minus my current number 7. So is 7 in the dictionary? No. So I skip here. I go to this statement right here. And then my dictionary looks like this. So So nums I is going to be 7, and then I is 0. So my dictionary looks like this. And then when I iterate to the second number here, then I see if target minus nums I, which is 14 minus 7, is 7 in the dictionary? Yes. So I'm going to return this mumbo jumbo, which is dictionary of 7, which is right here, which is 0, and then I, which is 1. So I know it's going to return which is the correct answer. Being able to walk through a test case and talk through your algorithm is really important. Let's see, after that, so you walk through test cases, explain to you how that works. That's pretty much all it is. I would say the meat of interviewing is really keeping the conversation alive. Like you don't want to be silent for more than, I would say when they give you the problem, you can ask for like a couple of minutes. Keep it as short as you can. But beyond that, you pretty much have to be talking the entire way through, which is really the difficulty of these interviews. And yeah, especially like the more difficult problems or when an answer doesn't come up immediately, it can be tough. And I would say, so this is like a perfect example where it's like the question wasn't too difficult, right? So I was able to talk through the brute force solution, talk through the best case, like my optimal solution, analyze all the runtimes and all of that. But in a lot of scenarios, maybe you'll hit a question where you don't know what the right answer is. You don't know what the best answer is, right? It's really important that you have an answer in general. So you can say, even if you don't have like what you perceive as like the best answer, you can start to say like, oh, so what I'm thinking about right now is X, because that's really important. Because even if you don't arrive at the best answer, if the interview has a good idea of how you think, that reflects better on you, right? If you show that, I can communicate well, and the other person is aware of how I'm thinking and what I'm thinking about, that's really good, right? So for example, let's say I don't know the answer to this problem. Where would I go, right? The first thing I would go say is, oh, I could probably iterate through, I could do a nested for loop. I think that's a brute force type solution, but I'll get the answer every time. It'll run O of n squared. And being able to recognize that is already a plus. And then the interviewer might even guide you in the right direction if you're having trouble. He or she will say like, oh, is there a data structure you might want to be able to use? Or is there a way you can avoid accessing the same element over and over again? Things like that. And for that, it's just, more practice is better. Like being able to, like think on the fly and come up with these answers is pretty important. But just in general, don't be too stressed out if you don't have the perfect solution every single time. As long as you left a good impression on the interviewer about the way you think and your ability to communicate how you're thinking, that's really good. Showing that your interviewer that you're able to look for edge cases, analyze runtime, look at trade-offs. These are all really, really good. And yeah, for the most part, beyond that, it's just, I would say, get a lot of practice of coding without like a run button or like a check button. I know a lot of like when I first started doing LeetCode or like these kinds of problems, I would just slam the run button and then it would just spit back at me a bunch of errors, and then I would fix each error as I got them, rather than like looking at my own code for errors. You get a lot of practice of like making sure your code is like meticulously correct and it runs well on the first try. Because just know that in an interview environment, there is pretty much that one try, right? You want to be able to get it that first time, rather than your interviewer pointing out, oh, you have an error here. Oh, you have another error here and another error here. And then your code works. Because then it shows that like this guy is kind of sloppy, right? You want to leave like as good of an impression as possible. And beyond that, it's learn to code without, the help of things like that. Like if you really want to challenge yourself, just open a Google Doc, open a notepad, and just read a question online and just solve it on that notepad, and then paste your code in and see if it works. Because honestly, if you interview for like some of the big companies, that's what it's going to look like. And not only that, you're going to be more nervous because you're in an interview environment and you have a person who is constantly wanting to hear what you have to say. So yeah. Beyond that, good resources, I would say CTCI is a good start. If you haven't taken data structures, take that as soon as possible. And yeah, just get a lot of practice. You can mock interview your friends. And it's really good. As I mentioned, like I think the key takeaways from this should be that it's not all. I would say 50% of the interview is about like arriving at that optimal solution, but I think the other 50%, or even more honestly, is being able to compare it to another solution, like a brute force solution, analyzing the trade-offs and the runtimes of all the algorithms, and why is it a certain runtime, rather than just saying, oh, it's O of n, oh, it's O of n squared, oh, blah, 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 right? Being able to know why. For example, like if you use any kind of sorting, it's probably n log n, for example. And yeah, things like that. Also keep in mind that if you finish a question pretty early, that can usually be good if you have covered everything you needed to cover, but don't feel rushed. Sometimes if you have a lot of time left, they're just going to give you an extension of your question or another one. So that's usually good if you covered all your bases, but yeah, just make sure that you've elaborated in the right way, and that you said everything you wanted to say, rather than like you just trying to speed run your question, because that's not what the interview is about. Like the interviewer needs to leave the room getting a good sense of how you think, and like being able to say like, oh, this guy can analyze trade-offs. This guy like knows why certain solutions are worse than others. And yeah, so that's pretty much it. I know the session wasn't as long, but I think it's too difficult to cover like all the kinds of questions you can cover in an interview. I'd say CTCI's topics are pretty good at that, as well as LeetCode's like top 100 interview questions are pretty decent for the most part. Some of them are like kind of iffy. But yeah, there's definitely a whole ton of topics to cover, and yeah, it's definitely a grind. So if anyone has any questions or anything, I can take that now.
There's some questions in the chat.
Oh shit! Wait, I'm trying to see. I'm trying to see how to pull up the chat. Hold on one second. Chat.
Do you want me to read them to you, or?
Oh yeah, I'm kind of dumb. So okay, I got it.
Okay,
oh yeah, I got it. Hi, since Python is an interpreted language and it takes longer to execute than Java, should we focus on an easier language or a faster language? Okay, so I know what you mean. So like Python's interpreted, right? So in terms of like practical, like let's say you're doing like a coding competition, right? Where like you have to actually compete for like runtime of like first place is like 0.03 milliseconds or something like that, right? In that case, like yeah, like I know everyone will use C or something, right? Because it's fastest. For these kinds of interviews, they care about big O runtime, or like practical, like theoretical runtime. And what big O really is like, let's say like two-sum I did here, right? Let's say I fed it like an array of 3 billion numbers, right? The O of n solution, or like the solution using the hash map, is going to be way faster than the one that uses like the brute force solution with the nested for loop. So they care about that kind of thing, like theoretical, long, like scaled runtime, rather than like, they're not going to say like, oh, use Java and Java's faster, so you get bonus points. No, it doesn't work like that. Like they're not going to say like, oh, Python is really slow, so they dock your points. In fact, that doesn't matter at all. Like any of the like any of that stuff doesn't matter at all. Your language is just preference, and for the most part, you want to use a language that the interviewer will know. They always know Python pretty much. They always know Java. They always know like the big ones. But the reason I recommend Java is because Python is because the syntaxes are so clean. Like as I mentioned earlier, like let's say I wanted to use a hash map, as a lot of these kinds of questions will utilize a hash map, right? I can just say, dict equals open curly brace, closed curly brace, and that's it, right? Whereas in another language, it would be like import java.util.hashmap, and then it would be like, hash map, like open whatever it is, like integer, like it's a lot of like, it's a big mess to even instantiate, and like you want to spend as little time and as little effort, getting your boilerplate out of the way. But yeah, in terms of like these the specific runtime speeds of languages, that doesn't matter. Like for an interview setting, they're not going to say, "Oh, you use C here. It's really fast. Good job." Like they don't care. In fact, they probably hate you if you use C because it's ugly. Like so, yeah, definitely recommend Python. Although I know some people who swear by Java, and that's fine too. Use what you're comfortable with. Okay, let's see. And then, what should you do if the question is hard level or difficult medium and you blank out? Actually, so I can speak a little bit to that. Like my very first interview was Bloomberg, and they gave me a question. I literally froze for 3 minutes. Like that was my worst interview ever. And like, um, just know that like even no matter how good you are at LeetCode, like you can imagine like some of the best people who are the most prepared. Interviewing is still like a hit or miss because sometimes you're just going to get questions that are like ridiculous, and that like is definitely up to chance, to be honest. So don't think like there are like people out there who would like just ace every interview. Like the best thing you can do is apply to most places, practice as much as you can to increase the odds that you can like come up or think of a solution. In terms of like LeetCode hard questions, I would strictly avoid them. Like so, like not as like a show off, but just as like an example, I've done on the LeetCode website, I've done 2 hard questions lifetime, like ever, which is like pretty much nothing. And I don't even think I solved them. Like I don't even think I did well on them. But like so in getting offers from like, so I passed like, I've interviewed for like Google, Amazon, Facebook, like all the big companies. And in my experience, like they have never asked me a hard question or like what is defined as a LeetCode hard question. So on that end, don't solve those. Like I would not practice those in the beginning. If you have extra time, once you're pretty comfortable with most of the easy and medium questions, maybe you can delve into that a little bit. But I think especially for internships, they won't really touch you on that. And the other point of your question is like, oh, if the question's difficult or you don't really have a solution, the best thing you can do, like, so the worst thing you can do is to freeze up and not say anything and just sit there, right? The best thing you can do is you can just say like, you can honestly be honest. You can be honest and just say, oh, I'm not really arriving at like the optimal solution right now, but this is what I'm thinking about. So currently like, and you can say literally what you're thinking of, just think out loud. So you can say like, oh, so I thought about using a queue here, or a queue here didn't really work, a stack didn't really feel right. I thought about using a hash map in the solution, or for example, like, let's say you had a question like for Tucson, you can say like, oh, I thought about sorting the array first, right? And sorting it and then using pointers like that, or just talk about all like exactly what you're thinking of. And generally speaking, like some interviewers who are nice will guide you in the right direction. Others will just let you think. Sometimes it's really hard. I like some questions are just going to be that difficult, and like you're not able to get anything, which will really suck. But for the most part, you make your chances the best by just thinking out loud, talking about your interviewer, and elaborating about what you think. In fact, actually, so one of my Google interviews, the question I completely did not know at all. Like I didn't really have a good answer for it, and I thought I was going to bomb it, right? But what I did in that situation was I just kept saying like, oh, I thought about using this, like X, Y, and Z, like all these different kinds of answers. And the interviewer got a pretty good sense of like what I was thinking about. And I communicated relatively well, I'd say. And so generally speaking, Google interns get like 2 interviews. That was my second interview. And while they didn't just give me an offer on the spot, they gave me a third chance at an interview because the interviewer felt like, I don't think this person passed, but I don't think I got a good sense of this interviewer's, competency. Basically, like, I think the question was a hit or miss for this person. And so yeah, you do the best when you think out loud and the interviewer gets an impression of you, regardless of whether you get the question right or not. Recording afterwards. I'm pretty sure we're gonna post it in the Slack or the Facebook or both. We'll make an announcement on the Slack at least. Let's see. If you're applying for a position where a specific language is a requirement recommendation, should you do the interview in that programming language? Let me see. So I know big companies like it's never like one language is required. It's more preference. But so for some startup-y or smaller or mid-sized companies that require like a specific language, I would say that when you have an interview scheduled, just contact your recruiter or whoever your contact is and to say like, oh, do you know what languages I'm able to use? They should be able to answer at least that much. Like, what language should I be, or am I allowed to use, etc. I think for the most part, it depends how specialized the position is, but I think for the most part, they should let you use like Python or Java for the interview portion, just because some languages are really, really tedious to work with, and like unless it's a very, very specialized role. I think for most intern positions, you should be fine. But yeah, just contact your recruiter. What was that first resource you mentioned that had good practice questions? Um, CTCI, or cracking the coding interview. Um, there are they go through like most of the big data structures that come up, and they attach like pretty simple questions that utilize these data structures after it, which I think is really great. So like they'll teach you about like a stack, and then they'll tell you about like maybe a common interview question where like a stack will work. Like let's say you need to reverse something, or stuff like that. Yeah. Yeah, thanks, Matt. The recording we'll post in the Slack after, I think. It'll probably be edited a little bit, so it might take a little bit, but yeah, it'll be up there. Yeah, other than that, any other questions or yeah.
I had a question. I was wondering, do you recommend going through like all the problems in cracking coding interview first and then going on to lead code, or how do you like balance out the two?
I would say uh so especially if you haven't taken data structures before, I would go through the first 9 or 10 topics on cracking the coding interview. It's not super imperative that like you do every single question on there, but I think like just even looking at some of the problems, like after you learn about like queues, right, and you look at some of the problems involving queues, you get a good sense of like, oh, these are the kinds of problems where a queue is in the solution, right? So you don't have to just necessarily like do every single problem, but yeah, so definitely if you're not comfortable with all the data structures yet, read through the first 9 or 10 topics in that book. And then Leak Code, I would say Leak Code is nice because you can filter by specific like specific things. Like so for example, like arrays, like hash maps, graphs, things like that. And so like you can touch on the points that you're particularly weak at. And yeah, I'm sure there's a lot of really great resources out there. It's I'm using actually some of the older ones, so there might be like some newer ones out there, but yeah, I'm sure like yeah, elements of programming interviews is great. I would say the biggest thing is get comfortable with thinking on the fly, using your data structures, talking while you code is a big one, and like trying to minimize your syntactical errors and things like that. Yeah.
Okay, thanks.
Yeah. So any other questions, or we can call it. Thanks for coming, everyone, by the way. I think we're good. Awesome. How do I stop recording?